Now we're recording. All right, so again, we're kind of doing logical reasoning. So what would you say logical reasoning is? Idea.
Like maybe why, but like the reason why it's like
So it's going to be based on some kind of logic. Now, it's not necessarily a proof. So we talked about that last time. Reasoning just means this is what we feel like makes sense. We're not getting into proofs just yet, but that'll be the next step where you use what's called a theorem or a postulate, something that has been proven before, and you're going to use a whole bunch of those to prove some kind of statement. Right now, what we're doing is we're just kind of saying, well, this is what makes sense. Some of them are going to be true, like when we get into some of the stuff later today, that like those are more true statements. They're called true statements. So sometimes they'll either be true, sometimes they'll be false. But for right now, we're going to go back and kind of review what we did last class with the conjecture and counterexample real fast. We didn't finish counterexample, so we got to finish that. Shoot. Let's see. How can I do this? Didn't really do that. Okay, tell you what, I'm just going to do it up on the screen for counterexample and conjecture. So look at page. So this is going backwards a little bit. The first page, 125, I think it was. If you were not here, this is mostly for you real quick. So we said that there's a definition for this word called conjecture. And the simple version is just, it is making a conclusion, drawing a conclusion based on a pattern. Did anybody not hear last class? All right, so 1%. So again, conjecture, the definition of that, making a conclusion based on a pattern. So if we see a pattern of numbers, 1, 2, 3, 4. Well, if we look at that, we see the pattern is they're going up by 1 every time. So a pretty good guess, again, this is not proving it. We don't know for a fact this is true, but a pretty good guess is that the next number is going to be 5. That would be our conjecture. So when I say on the quiz, make a conjecture, that means you're making a guess, estimate, whatever you want to call it, of what the next number might be. Or it could be a shape. So if we have, trying to think of one that's not already in the book. I have this. Oh, let's do this. I have this shape. And then I have this shape. This shape. So I have 3 shapes. And I say, what is your conjecture that the next shape would look like? Typically, these would be multiple choice. They're shapes. You don't have to draw anything. You can't really do that. What do you think the conjecture for the next shape would be? I'll call it. I get one foot upside down. So again, if you're visually looking at it, what you might hopefully see, there's 2 lines on the left, then 2 lines on the bottom, then 2 lines on the right. So we would probably be pretty logical if we assumed or guessed that the next shape would have 2 lines on the top. Again, that would be, again, we don't know that for a fact. We don't know that's for sure what the next shape is going to be. We're making our best guess based on a pattern. There was also something with like appointment times, like the appointment times were 45 minutes apart. You guys hopefully remember that. So now we said then there's this other logical reasoning definition called a counterexample. So now turn to page, this is one we didn't do. Turn to page 128. And we talked about a counterexample. So if you are going to disprove a statement, like say, no, that statement is not true, and you want to do it using a counterexample, you just need one counterexample, one situation where that statement is not true. So we did yesterday, Gavin, for you, we said, well, NBA players average over 6'6" tall, so all tall players must be good at basketball. We said, well, wait a minute. That's not necessarily true, because what if we know a tall person, like a really tall person, that's not good at basketball? That would be a counterexample. Something that is, I wouldn't say the opposite's the perfect word, but it's a statement that we can make that would be contrary to the statement that we're trying to figure out whether or not it's true. So look at the example in that number. God, I really need to put this up on the board and do it. Earlier. Oh, not. This back a couple of pages. Counterexample. I'll just zoom in here for now. So it said, now a lot of these in the book, which means probably on the quiz, a lot of them use numbers. So they're not like the basketball thing, they use numbers. So the statement would be, if n is a real number just means pretty much any number that exists, as far as you're concerned. You haven't gotten to the imaginary numbers yet, which there is such thing as imaginary numbers. If n is a real number, then negative n is a negative number. So that is a statement that we are trying to say is either true or false. So we haven't gotten to this thing called truth value. We'll get to it. We really should have done it first, but both will come second. So we want to know, what is the truth value? That just means, is that true or false? That's all truth value is. If I ask you what's the truth value, your answer is either true or false. It's true or it's false. It's all truth value. Don't worry too much about the definition of that. Just understand, I'm just trying to figure out if it's true or false. So the way we could prove that it's false, we can't really always prove something's true unless we do a full proof. But we can prove something's false if we can just come up with one example when it's not true. So, does anybody have an example when that's not true? And again, if we can't come up with it, again, we haven't proved that it's true, we just can't prove that it's false. I guess I'll go ahead and throw kind of Russian. A equals 0, negative. Yeah, 0 is the example. And I'll tell you right now, with numbers, a lot of times 0 is the counterexample, because it just has very different properties from other numbers. So keep that in mind. A lot of times 0 is the one you want to check. Sometimes 1 or -1 could be as well, because that again, they have kind of unique properties. But yeah, so negative. So again, if n is a real number, that means it should work for any number. So we're going to try 0. So negative n then would be -0. Well, there's really not any such thing as -0. It's just 0. And that is not a negative number. So this statement where it says negative n is a negative number, that's false. We just did it. 0, that's a real number. We made it negative, which really doesn't have a negative. It's just still 0. And that's not negative. So that is a counterexample. We came up with a situation where that statement is not true, and we only have to do that once. Just got to come up with one of them to be able to say, no, that's a false statement. I want you to try to do B. That one's a little trickier, but it's a good type of question to walk through. So try to do it on your own first. I'm gonna run and grab those. Press wheel switch. And you can read through the example, but try to do it without reading through the example first. You got to ask all the time, why do I need to know this? Why do I need to know this? Well, this works on your reason, your logic, which is very important in life in general, but certainly in God. You're doing stuff that's people are like, why in the world would you do that? That's probably not a good. All right, so let's talk about that one. So again, the statement is, this is the statement that we're saying, okay, is that a true or false statement? Can't really prove it true by just doing this one counterexample thing, but we could prove it's false. We can definitely prove it's false, just can't always prove it's true. That's when we have to write like a full proof to do that, which we'll get into later. If angle ABC, scroll up. So if angle ABC, so if that angle is congruent to DBE, and again, they really wouldn't have this figure there. You would have to come up with this. Then they must be vertical angles. So vertical angles would look like this. So again, keep in mind, they've kind of done it for you. Like you looked at the picture earlier, you really shouldn't have been using this picture. Do these two angles have to be vertical angles because they're congruent? Well, they just drew a picture where those two angles are congruent and they're not vertical. So that's a counterexample. Okay. Just because two angles are congruent doesn't mean they're vertical. We can have two angles that are congruent in different parts of a figure not even close to each other. Like I could have two angles in a triangle that are congruent. Like I could draw a triangle like this. And I could say those two angles are congruent right there. That's what those marks mean, congruent. Well, they're not vertical angles. They're two angles at the opposite sides of the base of the triangle, but they're not vertical angles and they are congruent. So again, that would be another counterexample, the triangle. Triangle's a counterexample. This picture here is a counterexample where we could draw a figure and say, oh, well, ABC in blue is the same as that, and they're definitely not vertical angles because vertical angles have to be across from each other like that. So that is not a true statement. We can come up with a bunch of counterexamples. What if the statement was the opposite? And it said, again, you would not have a drawing, so ignore these drawings. I mean, you can think about that drawing, because that's what I'm doing. If I said, if angle ABC and angle DBE are vertical angles, then they are congruent. Is that, can you come up with a counterexample of that? Is there any situation when vertical angles are not congruent? A lot of this is just logic. If you're not getting it, then you just have to do a lot of problems. I'll try to come up with extra practice problems for the, well, IXL, I think. You know what? Yeah, we've already said that. We've already said that is true. There is no exception to that rule. There's no counterexample because vertical angles are congruent. So that would be a true statement because we've said that before. We've actually sort of proved it out using like the fact that two linear angles add up to 180. Well, then that means so this is a quick proof of it. and this is what we'll get into later with statements. Well, if I know that these are vertical, so we'll just use numbers, angles 1, 2, 3, and 4. Well, I know that angle 1 plus angle 2 have to be 180. Right? Like we said that if two angles sit on a line, they have to add up to 180. Well, angle 2 plus angle 3 also has to add up to 180. So if I'm adding 1 plus 2 and getting 80, but I'm also adding 3 plus 2 and getting 180, then 1 and 3 have to be the same number. That's the only way I can get 180 both times. There is a little short proof, I think, that we might wind up doing later when we get to proofs, that same exact proof. But for right now, just using logic, that's why that's a true statement. So now that we know that's a true statement, we can then use that in other proofs to prove other things, and that's how proofs work. You're going to use statements that have been proven to be true, and then if they've been proven to be true, you can use them to prove other things are true. Look at the check problem. Try that one real quick. Not sure what time we're going to start assessment. We'll get through as much as we can. So look at the check. So this one again is with numbers, which think numbers are sometimes easier than statements that are not specific to numbers. So real number just means any number. Fractions, decimals, square roots, everything is a real number. It's multiple choice, so a pretty good example of what you might see on a district test for sure when you do the next module assessment, module 3, which probably will come up sooner than I think. All right, so if n is a real number, again, that just means n could be any number. It says then 1 divided by n, just as an example, we'll take 10. Let's say n is 10. Well, then 1 divided by 10, because again, now I'm just putting 1 over the number n, has to be less than n. So 1/10 is less than 10. Well, it makes sense in that particular number. Like if we choose 10, then it works. But remember, we only have to come up with one example where it doesn't work. Where if we choose a number for n, and then we put that number on the bottom of this fraction, it is not less than n. So basically the fraction would not be less than the original number. I'm going to go ahead and ask Google on this one. What do you think? So can you come up with a counterexample to that? And again, n can be any real number. So -3. So n equals -3. So what we would do then, so here's how you test it out. You pick a number, just pick one, and try some unusual ones. Don't just pick like 1, 2, 3. Like don't pick all the numbers in the same kind of like same category is not the right word, but like 1, 2, 3, 4. You're not really doing anything different with 3, 4, 5, 6, 7, 8, 9, 10. Negative though would be pretty different. That's significantly different than picking a positive 10. So -3. 1 then over -3 is what I'm comparing. So they're saying this number should be less than -3. So they're saying that should be the case. That's what the statement is saying. Now here's the real question. Let's do that one first. I'll come back because there's a bunch of them. So how do you know if that, now you got to know how to test that out. Is that a true statement? How do you test that out? You guys do need to know how to test this out. This is a not even a logic thing. This is math you need to know how to do to compare two numbers. That can come up on all kind of PSAT, district tests, EOC, like all kind of tests can have something where you need to understand whether a number is greater or less than 1. So here's how you do it. First of all, convert it to a decimal. How do you convert a fraction to a decimal? You all need to write this down if you didn't know the answer to that. Write it down. To convert a fraction to a decimal. I'm gonna make you write it down every time you don't know. Yeah, I mean, yeah. In high school geometry, that's something you learn in elementary school. To convert a fraction to a decimal, take the top number and divide it by the bottom. So on your calculators, everybody do that. Top number divided by bottom number. Don't have one, there's probably one sitting around you. I have a few up here that I'll pass out. There. All right, take the top number divided by the bottom number. What do you get? It's still negative. Don't forget that it's still negative. That doesn't go away. Negative point, say it again. Negative 0.3. We don't round, well, no, we won't round it up. You don't round it off. Do not round off when you do this. So what do you actually get? Negative 0.3. Yeah, 3 forever. Now, if you would have said negative 0.3 repeating, I'd be fine with that. So the 3's go on forever. So the 3's continue forever. They never stop. The only reason they stop is because you run out of screen space on your calculator. Now, the way you would really write that, and you need to understand, and the reason why you can't, that's what I was going to do. So the reason why you can't round that off is if this number would have been just negative 0.3, you need to understand which number is bigger or smaller. So you can't round it off to compare them. When you do calculations, I still wouldn't round it off personally because that changes the value you would get if you round off way up at the 3. So now we want to know, is this number less than negative 3? How do you compare two numbers now that they're in decimal form? You all need to know how to tell if a number is bigger than another number, especially when they're negative. Those are the tricky ones. You should know a positive number is always bigger than. How do you compare two numbers? Use it. Think of a number line. So again, a number line would look like this. 0 is right here. Say, and the farther right you go, the farther right the number is, the bigger it is, right? And we can simply just look at positive numbers for that. If 1 is there and 2 is there, well, 2 is bigger than 1. 3 is bigger than 2. So the farther right the number is, the bigger it is. So now you just got to figure out where do these go. Well, negative 3 would be there, and negative 0.3333 would be way over here. It's not even up to the -1 yet. So again, negative 0.3 is farther right, so it is the bigger number, which means, is this a true statement? Not true, right? That's bigger than that. So we just found a counterexample for that. -3 said that statement's not true.
So 1/1, and that would be equal to n.
So again, all that apply means there could be more, and 1 would also work. So 1 is probably an easier one to figure out, frankly, as long as you understand there's no equal to part underneath that. It has to be less than. Is anybody still writing that? Writing it down? So I'll change colors. How about that? So again, now let's test. Actually 1/4 would also work too. If you have the number 1/4 and you put 1 over, actually do that on a calculator. I want you to try to figure out what is 1. So again, we're testing that, but if we choose an n of 1/4, that means 1 over n is 1 over 1/4. I want you to try to divide, then that's a division problem. I want you to try to divide it out. Well, that's what 1/4 is. So I want to know what is 1 divided by 1/4. I'm not gonna worry about it. Well, we wouldn't. What could you do to this? What did we just say you can do with a fraction? You convert it to a decimal, right? So I would just convert it to a decimal. Don't worry about putting it in as a fraction. We'll worry about that another, we have more time. Well, you're taking the number one and when you divide it into fourths,
Then
there are four, there are four 1/4, right? So you would actually also say that 1/4 doesn't work because the n value is 1/4, but then the 1/n value is 4. Well, 4 is not less than 1/4. So that one works also. 1 would work as well. If n is 1, then 1/n is also 1. Well, 1 is not less than 1. So 1 works as well. So all three of those first three numbers work. You've got to know how to test those out. So all of those are counterexamples, meaning that's definitely not a true statement. All we needed was one, though, to say it wasn't a true statement to be a counterexample. Number or letter B is a little trickier. It's not about numbers. Think about B and try to draw. So here you'd have to draw something to tell you that it was or was not a counterexample. Say if it's true or false. So see if you can think of a way. So it talks about a line intersecting a segment at its midpoint. So first of all, you'd have to draw a line segment and like approximate where the midpoint would be. And then it says, so if a line intersects at a midpoint, then it is a perpendicular line, and that's. I want you to think about that and go over it. We're not going over it yet. What do you think about it? Sitting there not thinking about these, you're going to struggle on the quiz. And if you take this quiz this quarter, probably will not go on this quarter. Well, you'll definitely take it this quarter. I don't think we'll get it in next week though, because we have to do it like Thursday or Friday, and I think you have PSAT testing week, so you'll probably go back to Mondays, and it won't count for this quarter if we don't take it until not like in 5 days, more like in 12 days. Exactly. So if we don't take it until the last week of the quarter, it's not going to go on this. Odds are it's going to be a while before you take it. Make sure you're practicing it. It'll be pretty old material by the time we clear it. Your deadline is the 29th for that oh, did I mention this video? There's a review video just on the midpoints. Like it's like 9 minutes long. So if you just watched that video and came in and just did the midpoint section, it tells you how to use the formula, which I will keep up during class. That is on the formula sheet. So if you watch that video and you come in and take just the midpoint quiz that's due Friday, you should get at least a B on it, 80%. Because it just basically tells you exactly what you need to do on the quiz. Just 2 problems you have to get right. All right, so if a line segment intersects another line segment at the midpoint, what does perpendicular mean? Doesn't mean that they cross. It means more than that, 90 degrees. So it means that when they intersect, one is at a 90-degree, or actually they'd all be 90-degree angles. You can't have one 90-degree angle. So if this line, oops. So if that line intersects and creates a 90-degree angle, well, that means that has to be 90, that has to be 90, and that has to be 90 because of the vertical angles and adding up to 180. I'm calling something else. So Ben should call it Camille. Oh, she's up. So if a line intersects at its midpoint, so the first thing I gotta do is draw a line. Oh, that's a line segment. The midpoint would be about there. So it's saying if a line intersects that segment, then it has to be a perpendicular line. Is that true or false? You come up with a counterexample. So how could it, like, what's a counterexample then? You've got to draw it. I mean, you can explain it. I'll draw it. So explain it.
Yeah, the line.
Yeah, it doesn't have to go straight up and down at perpendicular. All it says is it intersects at this point. I can draw a line at any angle that intersects at that point. That's a line right there that intersects, it's not perpendicular. So that is a counterexample. So sometimes it'll be about numbers, sometimes it'll just be about you being able to think of an image. On the quiz, there are some that are not numbers. You have to be able to explain what a counterexample would be. I don't know if you have to draw any on there. I don't really remember. All right, so that's counterexample. So you have your problem set from that particular lesson. That's the whole lesson, is just conjecture and counterexample. So again, page 129, 1 through 16, that's conjecture, like patterns. And then I think it's the next page, page 130, but just the next numbers are 18 through 23, that's counterexample. Yeah. Fine. Don't have a memorized. We got, I can tell you that.
If I could, if I,
You can always retake, so. Either lunch, or you can set it up with me to do it after school, if after school is better. All right, so we're done with that chapter. I'm gonna just quickly. All right, we'll start there. We have not even gone nearly far enough, but. So go ahead, put all your stuff up. You need a calculator. You can have a blank sheet of paper out if you want. I will pass out formula sheets, but I don't know what's on this assessment, so you need the full formula sheet for this. I can find it up there. Do not write on these. This one class set in the same way for the test. Don't write on the test. Basically, just write on your scratch paper. This is not going to be a grade for my grade book. I will give out little, like those little prize books again, like I did last time. If you do better on it, then I think you had to be, I don't know what it was, like 60% or higher or something like that. It wasn't anything crazy. So, still, but mostly it's for you to see how the district asks questions. Because your district midterm is part of your grade. It's a big part of your grade. 20% of your semester grade. So this is a good way to kind of see where you're at on district tests, which can often be very different than my tests. So as soon as I get it, you can start reading. Oh, you need a blank piece of paper to write your answers on, even if you're like, because that's what we're going to take your lab and input. If you don't have any paper, I'll get you some, but don't do your answers on the test. Do not, you don't. So make sure you clearly label your, like the number you're working on the answer, because that's all we're really taking it aloud, is just what I get to consider to be your answer sheet. So I do your work on another page, like don't put your work and your answers on the same page. Again, if you need a scratch piece of paper, I'll bring you a scratch piece of paper, but I want you to have just answers on one page. 1, 2, 3, 4, 5, 6, 7. I don't know how many questions there are. It's like 18 maybe. Want just a page with answers, and I'll bring you around scale. So I don't know how long it's going to take them to input. I gotta get to just input, but it takes a minute to get logged in. So I'll give you probably about 30 minutes to do this, and then we'll hustle down to the lab. But don't get stuck on any one problem. Make sure you go through all of them first and just answer any that you are absolutely positive how to do. And do 30 minutes probably. We'll see. We'll see how everybody's doing. Go ahead, start. I'll bring reference sheets around now. So there should be some stuff where you need the reference formula, 3D shapes. Okay, that's what I should. Yeah, do not write on the test. Do not write on the test or your answer sheet. Like it should just be a number and an answer. If you need scratch paper, I'll bring around scratch paper. Give you. Oh, good. Two sides to the reference sheet. So we'll set it for now for 30 minutes. Actually, you can set it for 25, so I can kind of check and see where. Raise your hand if you need scratch paper. Just on an answer sheet. Number and an answer. The work on one. So back to that. So back to. This answer. You have to. You want one or? No problem. Perfect, we got. It's going to. We're going to. Multiple choice and the number. You're gonna work anything out, I'll put in 2 pages. Number of the question and then what your answer is. That's all we're taking the two classes. You can work some of them out. You can work them out. If you can't, then just. You have to guess. Which one you see.